All right. Hey guys. So I am going to go and walk you through the second part of this week's major assignment, research assignment. So the first video that you should have already watched on Edpuzzle and the Frayer model that you should have already filled out was looking at a particular object that you use on a regular basis. Now, today we're going to take that a step further and we're going to think about a particular material in that object. Great. So you should have already completed this first part, the first Frere model, step one, looking at a particular object. If you've not, please go back and do that first because this will be very, very difficult for you otherwise. So step two, look at the materials that you listed in your previous Frere model. So go back and look over here in this box, the top right box, about what are some of the common materials that might be found in your object. You're going to choose a material. Choose one of the specific materials in that list. You can honestly use any of those things. They should all be appropriate. So I could choose one of the natural options, like the hair of the or one of the animal hairs, or the one of the types of hardwoods, or I could choose one of the synthetic materials. So I decided to think about specifically in the type of hairbrush that I have, the handle being made of what is this polyacetal, because I know nothing about this material. So we're going to be focusing on, you need to now go and choose one of those materials that you're going to be focusing on for this second Frere model. Great. So once you've chosen that, you're going to write that in the middle, either on your Frere model that I digitally created for you in Google Sheets that was attached to the assignment where you probably found this. Or if you're doing it on your own piece of paper, please just put that in the material in your object circle in the middle. I'm going to do polyacetal, and I think that that's how you pronounce it, but I am honestly not all that sure. Now, again, you are not going to be doing the exact same thing as I am. So this is not a traditional notes where you're just filling in what I've done. Instead, I'm trying to walk you guys through exactly what you're supposed to be doing. But you need to be doing it for your particular material, like you did it for your particular object. So today, this Frere model is going to take a little bit more research because, like I said, I honestly don't know anything about this particular material. So like I kind of described to you guys in the first video, I purely just went and I Googled polyacetal, looked it up. And what I found first was that it actually was often known as something else. It was known as polyoxylmethylene, which is also POM. So that's why I also put those in the middle here. So if you find any other common names for the material that you chose, put that in there. I went to the Wikipedia page and I started reading a little bit about it. And what I found is that it is a synthetic, which means man-made polymer. We've learned about that in our previous assignments. It's usually colorless and opaque. Remember, we had opaque as a vocab word last week, that it means that you can't see through it. But you can, and it's usually white, but color can easily be added. Okay, that makes sense. If we're talking about my hairbrush, that could be any color. It's got high strength, hardness, stiffness, and rigidity. And this just straight up was in in the definition of what this material is, of what polyacetal was. I also, as I read, it said that it has low water absorption, so won't take in water. Can take high abrasion. So abrasion meaning like it can take a lot of wear and tear, which is what we want in our hairbrush. And it's heat resistant. Okay, cool. So take a minute now to go and to look up take a minute to go and look up your material that you chose that you're going to be researching and come up with some of the properties of that material. Do that now. So you're going to put this in the top left box, just as I did. Now, the next piece of this, I was again able to find these directly in the Wikipedia page that I was looking at. You might have to go back out to your Google search and like type in what their molecular structure of whatever. But I want you to find some pictures that show what your material looks like. So my guess is that polyacetal, because it has the word poly, is probably a polymer. So I know that it's going to be some sort of long chain. And when I went and looked, there was just some pictures. It said that it described it as being crystalline, and it gave its chemical formula. I included that. You don't necessarily have to, but later on the next box, it says what are the elements in the material. So that was kind of useful, and that's why I kept it there. Now, as for some pictures, all right, it said it was crystalline. So if we think of like a crystal, it's kind of got like this really organized, tight structure to it. And these were the pictures that I found. So see this kind of crystalline, tightly, neatly organized structure, but still looks very much like a polymer. And then down here, we see that CH. Those are two H's. Sorry, it's blocked right there. And that oxygen. That N means that this kind of subunit, this monomer subunit, can be repeated over and over and over again. Okay, that's what makes it a polymer. All right, so you need to take a pause, go look at your research that you are finding. If you're filling this out on the Google Sheet, you can just copy and paste some pictures in here. Don't make this more complicated than it needs to be. If you're filling it out on your own paper, you might have to draw some pictures, but do your best. I know this is kind of, it might be a harder thing for you to draw, but do that right now. Go look up your material. Look up that material and see what is the molecular structure of that material. Great. So as I'm starting to think about this is all making a lot of sense. So polyacetal appears to be a really long polymer. It's crystalline, meaning it's highly structured, and it looks like it is pretty linear and tight. And if I think about what we've learned previously about what makes different polymers useful for different things. Polymers that are in long chains, they tend to be maybe a little flexible, but they do have the ability to form the most structure. Because it's crystalline and appears to have some of these connections between them, that means it's going to be really strong. Well, my hairbrush handle is really strong because I've totally thrown it or dropped it on the floor before. So this is just really starting to make sense to me. All right, so the next box that we need to fill out is the top right corner. So what elements are in this material and how is this material made? I'll be honest, this was the one that I got most stressed out about, and I don't want you to overthink it, okay? So if it is a man-made material, there's some sort of process, and I don't need you to go into crazy detail, but find something that says how it's made. If you chose a natural material, then you don't have to say how it's made. It's natural. It's found in the environment. But so simple enough, what elements are in my material? Down here, I found out it's carbon, hydrogen, and oxygen. And then what I found out is that this material is made through a polymerization reaction. Again, this makes sense. Polyacetal, it is a polymer. So it had to have been made through some synthetic polymerization reaction. We learned about those in our ed puzzles from week 1. So try your best right here to see if you can find something about how your material is made. So when I was doing this, I saw some information about like a specific type of polymerization. Don't feel the need to put that down. It was like a anion or cationic, and that's over the top. The polymerization is the part that's important. So look that up now and add that to your top right corner box. Awesome. We are almost done with this assignment. So the last thing is I want you to think about what are some other things that might be made of this material. What also might be made of polyacetal. And why do you think that this material might be used in those things? So while I was on Wikipedia, I saw a list of a bunch of other items that are made of polyacetal. So I simply copied those down and put them in this box. And then I took a second to think about Why do I think that this material might be used in those particular objects? So I found that polyacetal is often used in high performing engineering components. So what that means to me is it's like components that are going to take a lot of wear and tear and have to move in some way. So gear wheels. So you think of like those small toys that have like a gear. Eyeglass frames. So they have eyeglass frames have to move. You're going to handle them regularly. They got to be sturdy. Ball bearings. So that's another kind of mechanical engineering thing. In ski binding. So that's really interesting. If you've ever been water skiing or snow skiing, that's what allows your boot to lock into the ski. And it's going to take a lot of stress. Different fasteners, so maybe like buttons, in different parts of guns or knife handles. Interesting. Handles. So polyacetal might be used on many things that are handles, like our hairbrush, or also lock systems. Excuse me. So, thinking about my hairbrush and why it's made of polyacetal, and then thinking about these other objects that have polyacetal in them, it makes sense because polyacetal, these objects, hairbrush, need to be sturdy, need to be rigid, and are high use items are things that need to be able to take a lot of wear and tear. And it appears that the crystalline, strong, rigid structure of polyacetal is why it is a perfect material to be used in these kinds of objects. Take time right now to look up what are some other materials that are made by polyacetal. If you have to Google that, great. If you just are able to find that in your Wikipedia search that you are on right now, awesome. But write that down and then spend a second to think, why does it make sense that all of those objects, including your object, are made of this material? All right. So awesome. You should have a completely filled out Frayer model. Again, if you did it on the digital sheet that I shared with you, all you have to do is make sure that it is assigned to the assignment when you turn that in. If you wrote it down, please try your hardest to snap a picture. I really liked getting the pictures of y'all's notes from the week 1 notes assignment. Take a picture and upload that to then make sure you mark it as done, making sure that your assignments are attached, and you're good. You finished this research project. I hope you guys learned some things about different materials and thought about why different objects are made of different materials. Okay, good luck on your quiz. See you all next time. Again, stay safe, make good choices. See you later.